Section 6.7 is on quadratic equations and problem solvings. Our objective is to solve problems that can be modeled by quadratic equations. Often in problem solving, you need to translate written sentences into algebraic expressions. That's what we'll get to practice in this example. We want to represent each given condition using a single variable x, the length and width of a rectangle whose width is half the measurement of the length. Let's begin by assigning the length the variable x. So the length is equal to x, and the width is half the measurement of the length. So the width would be 1/2 x. In part B, we want to express or represent two consecutive integers. So let's begin with the first integer. We can assign the variable x. And then the one immediately following would be the next consecutive integer. The next integer is found by adding 1 to the previous. So x and x plus 1. Those would be the two consecutive integers. In part C, we're looking at the base and height of a triangle whose height is 3 less than 5 times its base. So let's assign the base a measurement of x and then translate the written sentence into the algebraic expression for the height. The height is 3 less than 5 times its base. So 5 times the base is 5x, and 3 less than that is found by subtracting 3. So the base is assigned x, where the height is 5x minus 3. Use the information given to solve the following problems. In part A, we have the area of a square is 144 square feet. Find the length of its side. We know that for a square, that all the sides have the same length. So we can assign x as the length of the side, and x is the length of all of the sides. We know from our basic geometry equations that the area of a square is length times the width. So the area, which was given as 144, is equal to the length times the width, or x times x. We can write this equation as x squared is equal to 144. Now in the previous section we talked about solving quadratic equations using the zero factor property. We want a zero in this equation, so we're going to subtract 144 from both sides. And then we can use the factor property. We get x squared minus 144 is equal to 0. If we know the factors, then we could set each factor equal to 0. Recognize that this quadratic equation, so we can factor that as a difference of squares as x minus 12 and x plus 12. And now we can use the zero factor property by setting each one of those factors equal to 0. We can say x minus 12 is equal to 0, or x plus 12 is equal to 0. By solving, we get x is equal to 12, or x is equal to negative 12. Now, since x is the length of the side of the square, then it wouldn't make sense to have a negative value for your x. So we can say that the correct option is x equals 12. But anytime you start with a word problem, you should end with a word problem in the way that you write your final answer. So we can say the length of the side is equal to 12 feet. Since the units we were given is that the area of the square is 144 square feet, so each side is 12 feet. For example B, we know the area of the circle is 81 pi square inches. Find the radius. We know that the radius of the circle extends from the center out to the side of the circle, and let's label the radius x. The geometry formula for the area of a circle is equal to pi times the radius squared. So we know the area given here is 81 pi, and that's going to equal pi times the radius squared, where our radius is labeled with an x. We can simplify this equation by dividing both sides by pi, and we get 81 is equal to x squared, or we can write x squared is equal to 81. If we can get the equation to equal 0, we can use the zero factor property. So let's subtract 81 from both sides to get x squared minus 81 is equal to 0. Then by factoring, noticing that we have another difference of squares where the factors of x minus 9 and x plus 9 is equal to 0. Now we can use the zero factor property and set x minus 9 is equal to 0 and x plus 9 is equal to 0. And solving each of those, we have x equals 9 and x equals negative 9. Now the negative is not going to make sense for this particular problem since the x is the length of the radius and the length is not measured in negative units. So we can say that the length of the radius is 9. We want to make sure we use the right units, inches, since our original problem was that the area of the circle is 81 pi square inches. So the radius is 9 inches. In this example, a roofer drops a hammer from the top of a 60-foot roof. The height of the hammer after t seconds is given by h equals negative 16 t squared plus 64. When will the hammer hit the ground? Since h represents the height in this example, we want to know when the hammer hits the ground. When it hits the ground, the height is going to equal 0. So we can set up this problem to solve by setting 0 as your height is equal to negative 16t squared plus 64 using the equation that's given that models the height of a falling object. Now we can solve this equation by setting it equal to 0, and we could do some factoring here. We can move these two terms to the other side by adding 16t squared to both sides and subtracting 64 to both sides of the equation. And then we get 16t squared minus 64 is equal to 0. And then we can factor out 16, since the greatest common factor of 16 and 64 is 16, GCF of 16. When we do that, we get 16 times the quantity t squared minus 4. And then notice that this is a difference of 2 squares, so we can continue to factor where the two factors are t minus 2 and t plus 2 is equal to 0. Now we can use a zero factor property and set each factor equal to 0, beginning with t minus 2 equals 0 or t plus 2 is equal to 0. So we get t is equal to 2 or t is equal to negative 2. Now it wouldn't make sense that the time is negative 2 when the hammer hits the ground, so it would make sense that at t equals 2 seconds, the hammer will hit the ground. So when will the hammer hit the ground? The hammer will hit the ground in 2 seconds. The hypotenuse of a right triangle is 6 inches more than the shorter leg. The longer leg is 3 inches more than the shorter leg. Find the length of all 3 sides. In order to solve a problem that involves the side of a right triangle, we can use the Pythagorean theorem that says if we have sides A, B, and C, then the Pythagorean theorem says where A and B are the legs of a right triangle and C is the hypotenuse, that A squared plus B squared is equal to C squared. And we're given some information about the lengths of each of these legs. We know, let's begin with the shorter leg. We can let A equal X. the shorter leg, and the longer leg is 3 inches more than the shorter leg, so that's the longer leg is B, 3 inches more than the shorter leg, that would be written as x plus 3. And the hypotenuse, which is C, is 6 inches more than the shorter leg, so that's going to be x plus 6. So those are the lengths of the 3 sides of the right triangle. Then we can plug them into the Pythagorean theorem. A squared plus B squared is equal to C squared, where A is equal to x, so we get x squared, plus B, which is x plus 3 quantity squared, equals C, which is the quantity x plus 6 squared. Now we want to solve this equation, but it's going to involve doing some algebra here and writing this as a quadratic equation. So let's begin by simplifying both sides of the equation. We get x squared, and then x plus 3, the quantity squared, can be written as x plus 3 times x plus 3. And x plus 6, the quantity squared, can be written as x plus 6 times x plus 6. We got to expand this, so x times x using the first, outer, inner, last. We get x squared plus 3x plus 9. And on the right side, using first, outer, inner, last, we get x squared plus 6x plus 36. And then by simplifying the left side and the right side, the left side we get x squared and x squared, that's 2x squared. We're combining like terms, plus 6x plus 9. And on the right side, I get x squared plus 12x plus 36. Now we want to use a zero factor property to solve a quadratic equation, so we want to have a zero in the equation. In order to do that, we're going to subtract x squared from both sides of the equation. We'll subtract 12x from both sides of the equation, and we'll also subtract 36 from both sides of the equation. By doing that, we end up with a quadratic equation that's in the form of x squared minus 6x minus 27 is equal to 0. Now we have a quadratic equation. If we find the factors, we can use a zero factor property. So you want to find the factors for x squared minus 6x minus 27 by looking at the factors of negative 27 that will add up to negative 6, and that's negative 9 and positive 3. Multiplied gives you negative 27, and add to give you negative 6. So the factors are x minus 9 and x plus 3. Now we can use a zero factor property by setting each one of those factors equal to 0. So if x minus 9 is equal to 0, we get x is equal to negative 9, and x plus 3 is equal to 0. Sorry, x equals 9 or x equals negative 3. So let's move over in this direction. We get, by solving each one of those, we get x equals 9 or x equals negative 3. Now since x is the length of the shortest leg of the right triangle, it wouldn't make sense to have a negative number. So we can eliminate that as a possibility. So let's go ahead and find the length of each of the sides of the right triangle, where length A is equal to x. So that means A is equal to 9. And we're talking about inches here, so x is 9 inches. B is x plus 3, so 9 plus 3 is going to give us 12 inches. And then the hypotenuse C is x plus 6, which is equal to 15 inches. So this triangle has the shortest leg of 9 inches. The longest leg is 3 inches more than that, which would be 12 inches. And the hypotenuse is 6 inches more than the shorter leg, so that's going to be 15 inches.